Hello everyone, in this video I'm going to be talking about how to do the resonance structures, and we also going to be predicting the most stable resonance structures among all the resonance structures you draw. Just go ahead and jump into it. We're going to look at the very first molecule. Always look at what particular type of resonance structures you can have on the molecule. We see that on the first one, I can probably make this a little bit smaller, we have this negative charge right there, or a lone pair of electron with a -1 formal charge on that carbon, and that double bond is going to be conjugated, but then eventually that double bond right here is going to be conjugated with that double bond on the carbonyl. That's an allylic lone pair, and if we see what's going to be your electron rich side and electron poor side, your lone pair is going to be electron rich side, relatively speaking, and then pi bond is going to be electron poor side compared to the lone pair. So my lone pair will go into the next position here to create a pi bond. Now remember, we cannot have an exceeded valency for the carbon. As a result, this pi bond will break, and we're going to have a negative charge on that next carbon here. Okay, so this should look like a new resonance structure that would have a double bond right here and a negative charge on that carbon. Now, moving along, this carbon here, or this lone pair here, now is conjugated with that pi bond here. So we can go ahead and have this come down here. And when that happens, the pi bond will break and it will go on to the oxygen as a lone pair. So we get another resonance structure, and that would look like this. So then your question is, which one is actually going to be more stable out of those three? And the first thing you really check for, gotta have a negative charge there. The first thing you really check for is the octet, and turns out you have every single octet completed on this first resonance structure, even though you have carbon with a negative charge, but it does have octet completed because remember, it has one more hydrogen here that's not really shown. Even the second one has the octet completed, and so is the third one has the octet completed. So if all your octets are completed, then you want to look for the fewest number of formal charges, and turns out every single molecule here, or every single resonance structure has one atom with a formal charge, so that doesn't help either. The next thing you'll want to look for, who is getting the negative or positive charge. So, you want to make sure if it's a negative charge, you want to put it on basically a more electronegative element. And in this particular case, turns out we have, for the first two, the negative charges on the carbon here and here, but on the third one, we have a negative charge on the oxygen. So that means this oxygen, being more electronegative, is able to handle that negative charge better. So that means this is going to be the most stable resonance structure. Now let's look at this next one here. All right, so on this next one, let's see what's really going on. We have an electron deficient side that's going to be the positive charge, and we got an electron rich side that's going to be relatively this pi bond, and that pi bond and that positive charge, they are indeed conjugated with one another. You can also say that this positive charge is at an allylic position with respect to that pi bond. So I could have one of the arrows looking like this, where this can move down here. So this pi bond moves down here. Now when that happens, let's see how the structure is going to look like. So we get a double bond right here. We get a positive charge right there. And then we also don't stop it right here, because there is a lone pair of electrons on that oxygen, and it's right next to that positive charge. Okay, so that carbon, being an electron deficient, and you have an excessive lone pairs on the next atom here, we can use those lone pairs of electrons to create a pi bond. So this is how it's going to move down toward the electron deficient side, and we're going to get another resonance structure here. So we use one of the lone pairs from the oxygen to create a double bond there, and oxygen gets a positive charge. So those are the possible resonance structures you're going to have. And out of those three, which one is going to be the most stable? So let's talk about that now. And turns out if you want to look at the octets first, on the first one, you got a carbon with a positive charge, so that's an incomplete octet here. On that carbon right there. And the kind of same story on this second one, that carbon is going to have an incomplete octet as well because it got a positive charge. So I'm going to go ahead and say that's in having an incomplete octet as well. But when we look at the third one, actually, we have, even though we get a positive charge on the oxygen, but oxygen still have all the octets completed here. And the other carbons are also happy in terms of the number of bonds they have, the valencies completed. So I can say all octets are completed here. So since you have all the octets completed, in this particular one, this would be the most stable. That's the very first thing you want to look for. Whichever structure gives you the most octets completed, that's going to be the most stable. Then you don't really have to look at the next things, which is like fewest resonance and who's getting the positive and negative charge. So that's the next thing you would look for after you focus on the octets first. Okay, let's look at the next one here. I can clearly see my electron deficient side is going to be this positive charge here, and then there is a pi bond right next to it that's going to be your electron rich side relatively. So I can have this move down here because that positive charge is going to be in conjugation with that pi bond. So when this moves down here, we will get a resonance structure that would look like this here. And where would the positive charge be? Well, this carbon all of a sudden becomes electron deficient, so that is going to get a positive charge right here. And then you can clearly see there's a negative charge right next to a positive charge. So I can have this lone pair coming down here for the next set of resonance structure to create a pi bond here. So when that happens, we will end up getting a double bond right here. Okay, so those are the resonance structures you can draw on this one. Now the question is which one is going to be the most stable? And we look at the octets first, and clearly we have an incompleted octet here, incompleted octet on the second one with the carbons getting the positive charge. And the third one, we have all the atoms with completed octet. And also there's really not any formal charge on the third one as well. But, first thing you want to look for is obviously the octets here. And since you have all the octets completed for the third one, that is going to be the most stable resonance structure. So this is how you're going to be drawing some of the resonance structures and predicting the stability.